Good morning, guys. Sorry I'm not there today. Today we were supposed to do more classifying of polynomials and writing them in standard form, but we're going to skip this part and we're going to go right to adding and subtracting polynomials. And then tomorrow when I get back, I will go over the other part with you. It is on the packet that you received. If you want to look at the first and second page, there are tables and charts that give more classification. And if you want to look through them, that would be great for when I get back. You can even try to classify some of the examples that are on your paper. But right now we're going to skip to the fourth page where it says adding and subtracting polynomials. I have removed some of the examples, so just try to stay along in your packet and make sure you're on the right example. We're going to start off with E. So this should be on the fourth page. And when we're adding and subtracting polynomials, basically we are still looking for like terms. And if you remember, like terms basically meant that we have the same variable raised to the same power. So here, s squared and s squared are like terms, but s is not because it is not raised to the second power. So if we were going to add these together, we would take 2s squared and 3s squared, and together we have 5s squared. And because this s is not raised to the second power, it just follows along. Here, looking at G, we have 2x to the 8th and 7x to the 8th. Nope, I'm sorry, 7y to the 8th. But we have a negative 1x to the 8th. So 2x to the 8th minus 1x to the 8th is 1x to the 8th, or just x to the 8th. We have a 7y to the 8th minus a 1y to the 8th. So 7 take away 1 is 6y to the 8th. So I've combined like terms. For f, we have 4z to the 4th and 16z to the 4th. So when we add those together, we have 20z to the 4th. And the constants are also like terms. So negative 8 plus 2 is minus 6. And last but not least, h, I have a b to the third c squared, b to the third c squared, b to the third c squared. These are all like terms. So we have to look at the coefficients. I have a 9 plus 5, which is 14. And then we take away 13. So I'm left with 1b to the third c squared. So really we're just combining like terms. So if you look forward to example 2a, now we're really getting into adding polynomials. Here is one polynomial. It's 2 terms, so it's a binomial, and this is 3 terms, so it's a trinomial. We are going to add these together, and it's just the same as what we just did before. We're going to look for like terms and combine them. The parentheses are here, but since it is adding, it doesn't matter that they are there or not. We like to write things in standard form. So I'm going to, when all the same variables are there, I'm going to look for the highest exponent first. So I have a 4m squared and a 1m squared. So together that is 5m squared. The next thing down would be the m to the first. There's nothing to combine it with, so I'm just going to take that and bring it down. And my constants are plus 5 and plus 6, so we have plus 11. And that's it. Let's look at b. These are not the same variables, so there really is no standard form. So you can combine it in the order that you'd like. I'm going to start with the 10xy minus 3xy. So that's a 10 and a negative 3. So that's a 7xy. And then we have a plus x, but no x is over here. So I'm just going to write plus x, and I have a plus y, so I'm going to write plus y there. And we just added 2 polynomials together. So let's try one more. Again, I'm going to scan this. I don't have the same variable across the board, so its standard form does not count. I'm going to just start here with the first term. 6x squared plus 3x squared is 9x squared. And then 9x squared minus 8x squared is 1x squared, which, of course, you know you don't have to write the 1. And all the other terms are just y's. So I have a negative 4 plus 3. Negative 4 plus 3 is negative 1y. Minus 2y together makes negative 3y. So when we add these polynomials together, you should get x squared minus 3y. Now, when you subtract, remember that when you subtract, it's the same as adding the opposite. So to find the opposite of a polynomial, you must write the opposite of each term in the polynomial. I like to think of this as a negative 1 out front. Instead of subtracting this, I'm going to just distribute my negative 1 to everything inside, and it becomes negative 2x to the third plus 3x minus 7. I just distributed a negative 1. So let's look at this in a problem. I'm going to subtract 2x to the third from x to the third plus 4y. So again, I consider this a negative 1, and I'm going to distribute it. Obviously, there's only one term, so you're just multiplying. I rewrite the first term without the parentheses. Negative 1 times 2x to the third is negative 2x to the third. Now I'm ready to combine like terms. I have x to the third minus 2x to the third. Remember, that's a 1, so 1 take away 2 is a negative 1 x to the third, and the plus 4y comes down. So subtracting is just like adding, you just have to distribute the negative 1 first. So if we look at example 3b, I see here that I have a negative 1. I'm going to rewrite the first one without the parentheses, and now I'm going to start distributing. Negative 1 times 5m to the fourth is negative 5m to the fourth. Negative 1 times negative 5m squared is positive 5m squared. Negative 1 times positive 8 is negative 8. Now I'm ready to combine like terms. If you notice here, they're all m's, so we can write this in standard form. So I look for the highest exponent, and that's definitely 7m to the fourth minus 5m to the fourth. So that's 2m to the fourth. Now you look for your next lowest exponent, which is 2. I have negative 2m squared plus 5m squared. So negative 2 plus 5 is a positive 3m squared, and the negative 8 attaches at the end. So again, this is just like adding. You're combining like terms. You just have to distribute the negative 1 first. Let's try another one. I'm going to rewrite the first polynomial without the parentheses, and now I'm going to distribute a negative 1. So that's negative 1x squared and positive 9. Remember, when you're distributing a negative 1, you're basically just changing all the signs of each term. Again, we only have x's, so I can write this in standard form. This is definitely the highest exponent. So negative 10x squared minus 1x squared is negative 11x squared. I only have one x term, so that carries down by itself. And I have a plus 7 plus 9, so that is plus 16. Let's try one more. I'm going to rewrite the first one. We're on example 3D. I'm going to put my negative 1 here and distribute. Negative 1q squared and positive 5. So 9q squared minus 1q squared is 8q squared. And negative 3q has nothing to combine with, nor does 5, so they come down, and that is how we subtract. All right, what I want you to do is pause this video. I want you to try these 5, come back, we'll see how you did, and then you have some activities to work on to practice this. Okay, so first I combine 7m squared and 4m squared. So that's 11m squared, and the plus 3m comes along because it's not an m squared, so I can't combine it. Number 2, we're subtracting. So I'm going to rewrite the first one as is. I'm going to distribute a negative 1 and get negative 5r squared minus 4s squared. They're not the same variable, so I'm just going to start with the r squareds. I have 1r squared minus 5r squared, so that's negative 4r squared. And I have an S